Hello students, how are you? Okay, let's start the chapter Ray Optics. First of all, you should know what is optics. Optics is the branch of physics that deals with the study of nature, production and propagation of light. It has two sub-branches, ray optics and wave optics. Ray optics is also called the geometrical optics. It concerns itself with the particle nature of light and is based on first is the rectilinear propagation of light and second is the laws of reflection and refraction of light. Wave optics is also called the physical optics. It concerns itself with the wave nature of light and is based on the phenomenon like interference, diffraction, and polarization of light. Now I will explain the laws of reflection of light. Laws of reflection. There are two laws. First law, incident ray, the reflected ray, and the normal at the point of incidence lie in the same plane. Number two is the angle of incidence I is equal to the angle of reflection R. That is angle I equal to angle R. These are two laws. Now, the properties of images formed by the plane mirrors. Properties of mirrors formed by the plane mirrors. Number one property is the image formed by the plane mirror is virtual, erect, and laterally reversed. The image formed by a plane mirror is virtual, erect, and laterally reversed. Number two is the size of the image is equal to the size of the object. Number three is the image is as far behind the mirror as the object is in front of it. Number four is the line of joining the object and the image is normal to the plane mirror. And number five is when a plane mirror is rotated through a certain angle, the reflected ray turns through twice the angle. Now, images formed by the inclined mirrors. When two plane mirrors are kept facing each other at an angle theta and an object is placed between them, a number of images formed due to the multiple reflections. If theta is a submultiple of 180 degree, then the number of images formed is n equal to 360 degree upon theta minus 1. If theta is not a submultiple of 180 degree, then the number of images formed is the integer next higher than 360 upon theta minus 1. For two plane mirrors, n equal to 360 upon 0, that will be infinity. Now, spherical mirrors. What are spherical mirrors? It is a mirror whose reflecting surface forms part of a hollow sphere. Spherical mirrors are of two types. First is concave mirror, in which the reflection of light takes place from the inner hollow surface. Second is convex mirror, in which the reflection of light takes place from the outer bulged surface. Definitions in connection with spherical mirrors. Definitions in connection with spherical mirrors. First is pole. It is the middle point P of the spherical mirror. Pole is the middle point of the spherical mirror. Number two is center of curvature. It is the center C of the sphere of which the mirror forms a part. Number three, radius of curvature. Center of curvature, now the radius of curvature. It is the radius R of sphere of the mirror forms a part. Number four is principal axis. The line passing through the pole and the center of the curvature of the mirror is called its principal axis. Number five is linear aperture. It is the diameter of the circular boundary of the spherical mirror. It is the diameter of the circular boundary of the spherical mirror. Angular aperture. It is the angle subtended by the boundary of the spherical mirror at its center of curvature C. Next is principal focus. A narrow beam of light parallel to the spherical axis either actually converges to or appears to diverge from a point F on the principal axis after reflection from the spherical mirror. This point is called the principal focus of the mirror. A concave mirror has a real focus, while a convex mirror has a virtual focus. Next is focal length. It is the distance f equal to pf between the focus and the pole of the mirror. Next is focal plane. What is focal plane? The vertical plane passing through the principal focus and the perpendicular to the principal axis is called the focus plane. The vertical plane passing through the Next is focal plane. The vertical plane passing through the principal focus and the perpendicular to the principal axis is called the focal plane. When a parallel beam of light is incident on a concave mirror at the small angle to the principal axis, it is converged to a point in the focal plane of the mirror. Now the Cartesian sign convention. Cartesian sign convention for the spherical mirrors. Number one is all ray diagrams are drawn with the incident light traveling from left to the right. All ray diagrams are drawn with the incident light traveling from the left to the right. Number two is all distances are measured from the pole. Number three is all distances measured in the direction of incident light are taken positive. All distances measured in the direction of incident light are taken positive. Next is all distances measured in opposite direction of incident light are taken to be negative. Next is heights measured upwards and perpendicular to the principal axis are taken positive. Next is heights measured downwards and perpendicular to the principal axis are taken negative. Now the relation between the focal length and radius of curvature. Focal length equal to 1 upon 2 into radius of curvature or f equal to r upon 2. Spherical mirror formula. What is the spherical mirror formula? This gives the relation between the object distance u and image distance v and the focal length f, and 1 upon f equal to 1 upon v plus 1 upon u. Linear or transverse magnification. Linear or transverse magnification. It is the ratio of the height of the image to that of the object. M equal to height of the image upon height of the object. H2 upon H1 equal to minus V upon U equal to F upon F minus U or equal to F minus V upon F. If m is greater than 1, the image is magnified. If m is greater than 1, the image is magnified. If m is less than 1, the image is diminished. And if m is 1, the image is the same size of the object. If m is positive, the image is virtual and erect. If m is positive, the image is virtual and erect. And f is negative, the image is real and inverted. Now the refraction of light. Refraction of light. It is the phenomena of bending of light from its straight path when it passes at an angle from one transparent medium to another. It is the phenomenon of bending of light from its straight path when it passes at an angle from one transparent medium to another. Laws of reflection of light. Laws of refraction of light. First law is the incident ray, the refracted ray, and the normal at the point all lie in the same plane. And second law is the ratio of the sine of the angle of incidence and the sine of the angle of refraction is constant. And this law is also known as Snell's law. And this will be equal to sine I upon sine r equal to mu. Mu is constant and mu is called the refractive index of the medium. Now, refractive index. What is refractive index? Refractive index of a medium for a light of a given wavelength may be defined as the ratio of the speed of light in vacuum to its speed in that medium. Mu equal to velocity of light in vacuum upon velocity of light in medium. It will be equal to C upon V. It may also be defined as the ratio of the wavelength of light in vacuum to its wavelength in that medium. Mu equal to mu lambda vacuum upon lambda medium. Refractive index of a medium with respect to vacuum is also called the absolute refractive index. Refractive index of a medium with respect to the vacuum is also called the absolute refractive index. The relative refractive index of a medium with respect to medium 1, the refractive index of medium 2 with respect to medium 1 is the ratio of speed of light v1 in medium 1 to the speed of light v2 in the medium 2. That will be mu12 equal to v1 upon v2. Or it can be written as mu12 equal to sine I upon sine r, and that will be equal to mu2 upon mu1. Or it can be written as mu1 sine I equal to mu2 sine r. Now, refraction through a rectangular glass slide. Refraction through a rectangular glass slide. A ray of light on refraction through a glass slide does not suffer any deviation. A ray of light on refraction through a glass slide does not suffer any deviation. That is, the incident and emergent rays are parallel, but the emergent ray is laterally displaced with respect to the incident ray. The lateral displacement x on passing through a glass slab of thickness t and relative index mu is given by x equal to t upon cos r into sine I minus r, where I is the angle of incidence, and x maximum will be equal to t sine 90. It will be equal to t. Thus, the displacement of the emergent ray cannot exceed the thickness of the glass slide. Refraction through a combination of media. Refraction through a combination of media. When a ray of light passes through a combination of media, the quantity mu sine I remains constant, where mu is the absolute refractive index of the medium and I is the angle of incidence in that medium. Thus, mu air into mu sine I air equal to mu glass into sine I glass. It can be written as A mu W into mu WG into GWA equal to 1, or W mu G equal to A mu G upon A mu W. Relation between real depth and apparent depth. Relation between the real depth and the apparent depth. Due to refractive index of light, the apparent depth of the object placed in a denser medium is less than the real depth. The relation between the real depth and the apparent depth. Due to refraction of light, the apparent depth of an object placed in a denser medium is less than the real depth. When an object O in a denser medium of thickness T and refractive index mu is seen through a rare medium, its image is seen at I. It is seen that mu equal to real depth upon apparent depth, AO upon AI. Also, apparent depth AI equal to T upon mu. The height through which an object appears to be raised in denser medium is called the normal shift. D equal to IO equal to AO minus AI, and that will be equal to T under the bracket 1 minus 1 upon mu. Total normal shift for combined medium is T1 under the bracket 1 minus 1 upon mu 1 plus T2 under the bracket 1 minus 1 upon mu 2 plus dash dash dash. Now the critical angle and the total internal reflection. Critical angle and the total internal reflection. The angle of incidence in the denser medium for which the angle of reflection in the rarer medium is 90 degree. I am repeating once again. The angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90 degree is called the critical angle of the denser medium and is denoted by IC, and I equal to IC and R equal to 90 degree. Total internal reflection. It is the phenomenon in which a ray of light traveling at an angle of incidence greater than the critical angle from a denser medium to the rarer medium is totally reflected back into the denser medium. I am repeating once again. Total internal reflection is the phenomenon in which a ray of light traveling at an angle incidence greater than the critical angle from a denser medium to a rarer medium is totally reflected back into the denser medium, obeying the laws of reflection. Now the necessary conditions for total internal reflection. First is light must travel from an optically denser medium to an optically rarer medium. Light must travel from an optically denser medium to an optically rarer medium. Second is the angle of incidence in the denser medium must be greater than the critical angle for the two media. The relation between the critical angle and the refractive index mu equal to 1 upon sine IC. Mirage. What is mirage? It is an optical illusion observed in deserts or over hot extended surfaces like a coal tar road, due to which a traveler sees a shimmering pond of water some distances ahead him, and in which the surrounding objects like tree, etc., appear inverted. Optical fibers. What is optical fiber? Optical fiber consists of thousands of fine strands of quality glass coated with a material of lower refractive index. Light entering the fiber at one end undergoes several total internal reflections and finally emerges out without any appreciable change in intensity. A, a bundle of optical fibers is called a light pipe, used in medical and optical examination and in receiving and transmitting the signals in telecommunications.